guys. All right, so today what we're going to do is we are going to do the properties of exponents, but we're also going to incorporate where you have rational exponents. That's where the exponents are fractions. So we've already learned our properties of exponents. So now the next thing that we're going to do is how do we apply that when they're a fraction? All right, so just to kind of recap, a radical expression contains a radical or a root, okay? So we've had sometimes numbers go in that little nook right there. So if it's a 3, it's a cube root. If it's a 4, it's the fourth root, and whatnot. A rational exponent contains a fraction as an exponent. Okay? So it contains a fraction as an exponent. So we can go from one form to another, and the way that we do that is just kind of reminder, we've done x to the power over root, just to remind you, okay? So if I had the cube root of x, well, the exponent with the x is a 1, even though it's not shown. Let me just put that so that it is a little bit closer to the exponent spot. So if it's not shown, we draw in a 1. So then we do its power over root. So this is going to be x to the power, the exponent is 1, over my root, which is a 3. Okay, so we can write it as x to the 1/3. Same idea if I want to write y to the 4/5 as a radical expression. I do the radical and I do the y. So y to the power over root. So this is going to be raised to the 4th power, and the root is 5. Okay? All right, so now just a recap of our properties of exponents. So when we have the same base, a times a to the m times a to the n, I can simplify it and write it as a to the, we take those exponents and we're going to add them, m plus n. All right, so likewise, if I have numbers as my base, it's going to be 3 to the, and then I can add those exponents. 2 plus 3 is 5. And I can actually simplify that further because I know 3 to the 5th is 3 times 3 times 3 times 3 times 3, 243. All right. So now when we have rational exponents, we're going to treat it the exact same way. So it's going to be 3 to the, and then we're going to add those exponents. So I'm going to just do it off to the side because it's fractions. So 1/2 plus 3/2 is 1 plus 3 is 4 over 2. So 4 over 2 is 2. So it's going to be 3 to the 2, and that equals 9. Okay, because 3 squared is 3 times 3. So what we can do is we add those exponents. So we do 1/2 plus 3/2, and we get 4/2, and 4 over 2 is 2. All right, so same idea when we apply the properties of exponents where we have a quotient dividing. So they have the same base, so we're going to subtract them, m minus n. So same idea if it's a number as a base, 5 to the 7 minus 2 is 5, and 5 to the 5th is going to be 5 times 5 times 5 times 5 times 5. I think that's 5 times that I said it, and that is 3,125. Whoa, I just wrote those right on top of one another. There we go, 3,125. All right. Next one, we have fractions. So same idea, 27 to the, and we can subtract 2/3 minus 1/3 is going to be 1/3. So that's 27 to the 1/3. But I can actually simplify that because power over root. So I know this is going to be 27, the power over root. So the cube root of 27 to the first power. The cube root of 27, that means what number times itself 3 times will give me 27? That's 3. So I can simplify that further. All right, for the next one, we've got power to a power. So it's going to be a to the m times n. So if it's a number base, it's going to be the same thing, 4 to the 3 times 2, 6. All right, and I can actually do that in my calculator or by hand. 4 to the 6th is 4 being multiplied 6 times together, 4 times 4 times 4 times 4 times 4 times 4, and that is 4,096. Okay? Now, for the next one, when we have a power to a power, it's going to be 4 to the 1/2 times 4 over 1. So that's going to be 4 over 2, which is 2. So it's 4 squared, which is 16. So I can simplify that to 16. All right. So now kind of talking about the powers of a product. So when you have two things being multiplied and it's being raised to the m, I can distribute that exponent to both things on the inside. So a to the m, b to the m. Okay, same idea here. It's going to be distributing the 3m to both of those exponents. So 3 to the 3rd times x to the 3rd. But that's going to simplify because I know 3 to the 3rd is 27. So 27 x to the 3rd. All right, so same idea. If you have a fraction, we can distribute that in. So it's going to be 25 to the 1/2 times 36 to the 1/2. All right, but we can simplify that. Power over root. So this is saying the square root of 25, that's 5, times power over root. That's saying the square root of 36, that's 6. 5 times 6 is 30. Simplify. Okay? So all these ones, when we get to the final answer, we can simplify them. All right, next one, power of a quotient. We can take that exponent and distribute it into both. So it's going to be a to the m over b to the m. Same idea for the next one. We do the squared to both of them. 3 squared over 4 squared. So that's going to be 9 over 16. Same idea when you have a fraction. You can distribute it. 27 to the 1/3 over 64 to the 1/3. But remember, it's power over root. So this is saying the cube root of 27 over the cube root of 64. So the cube root of 27 is, what number times itself 3 times will give you 27? 3. Over the cube root of 64, what number times itself 3 times will give me 64? 4. Final answer. Oh, you hear my dog whining in the background. All right, last one of these notes. We've got negative powers. So we've got, anytime you have a negative exponent, you can relocate it into the denominator and make it positive. So a to the n goes into the denominator and a 1 goes up top. So we can apply that with numbers. So 3 to the positive 2 now goes on the denominator and a 1 goes up top, but 3 squared is 9, so it's 1 over 9. All right, and the last one, this is going to be the same idea. So a negative exponent, you relocate it down into the denominator, 32 to the positive 3/5. Okay, and then a 1 goes up top. But then again, we have power over root. Oh, my dog is really whining, huh? The 5th root of 32 raised to the 3rd. All right, so we've got the 5th root of 32. That's 2 raised to the 3rd. So that's going to be 8. I can't stop laughing at him whining in the background. So it's going to be 1 over 8. Final answer. All right, so I'm going to pause now before we go to the next set.